This is lesson 4-7 from the Algebra Readiness textbook. For today's lesson, you will need a sharpened pencil in your notes packet. Pause the video while you work on these study guide problems. Continue the video when you're ready to compare your answers to mine. The first question asks me to evaluate and write the answer in simplest form. I need to substitute 6 in for x and 9 in for y. And then I need to simplify. I simplify by dividing the numerator and the denominator by the greatest common factor, which is 3. My solution is 2/3. The next question also asks me to evaluate. I need to substitute -3 in for m and 6 in for n. I keep in mind that anytime you substitute a negative number into an expression, I always put parentheses around it. So -3 minus 6 all over -12. -3 minus 6 is the same as adding the opposite. So -3 minus -6 is -9 all over -12. I'm going to divide the numerator and the denominator by the greatest common factor, which is -3. -9 divided by -3 gives me +3. -12 divided by -3 gives me +4. 3/4. For today's lesson, our learning target is to multiply powers with the same base and also to calculate the power a power raised to another power. I want you to look for a pattern or a shortcut while I demonstrate how to do 7 to the second times 7 to the third. You learned that 7 to the second in expanded form means 7 times 7. Then I'm going to multiply 7 to the second by 7 to the third, and that means 7 times 7 times 7. I am going to tell you that 7 to the second times 7 to the third is the same as 7 to the 1, 2, 3, 4, 5, 7 to the fifth power. Some of you might notice a pattern. The pattern I'm hoping you notice is that this 2, the exponent of 2, means that there are 2 7s multiplied together. This exponent of 3 means that there are 3 7s multiplied together. And then I'm being asked to multiply those, which means that there are going to be 5 7s multiplied together. The shortcut, then, would be to keep the base and add the exponents to get 7 to the fifth power and not have to write out the expanded form. It allows me to skip all of that work if I simply understand what this means and apply a shortcut. This is in your notes. To multiply numbers or variables with the same base, make sure you know it has the same base, you can simply add the exponents. So 2 to the third times 2 to the fourth, that means 2 times 2 times 2, and this means 2 times 2 times 2 times 2, which is the same as there are 7, 1, 2, 3, 4, 5, 6, 7 2s, 2 to the seventh power. I could skip all of that work by adding the exponents. You simplify an expression by doing as many of the indicated operations as possible. When you are done, then that is the simplified form. So in this case, simplify the expression. Let's recall, what is the exponent if it is not written? Hopefully you recall that 3 is the same as 3 to the first power. Now, if you are not there yet to getting good at using the shortcut or the rule of saying 3 to the 1 plus 3 power or 3 to the fourth, then it is absolutely okay for you to write this all out in expanded form. And in fact, It's important that you do so to develop an understanding of why the rule works. However you get there, the answer is 3 to the 4th power. Now remember, you can only apply the rule to like bases. So I could combine a to the 5th, which is a times a times a times a times a, and a to the 1st, which is another a. So a to the 6th, and then I leave it b to the 2nd. Do not call that ab to the 8th or something crazy like that. They are two separate quantities being multiplied together. I want to side mention here, you can put a dot there, you do not need to. All right, your turn. Pause the video and try the next 3 problems. Come on back and compare what you get to what I got. All right, for the first one, 2 to the 5th power is equals 32. It looks like this, and you get 32. Letter B, m to the 5th times m to the 7th. I simply add those and get m to the 12th. And in letter C, I get x to the 5th times, now remember there's an exponent of a 1, times y to the 5th. All right, now what if I have a coefficient? We haven't talked about those yet. Let's do this one with me in your notes as I do it for you. You're going to multiply. This is really -2 times x squared times 3 times x to the 5th. Isn't that what that means? It's just that when you have a number next to a variable, you don't have to write the multiplication sign. So really, I'm just using the commutative property to multiply my numbers together and then multiply my variables together. -2 times 3 is -6, and then x to the 7th power. You do not need to write all of this out. If you're somebody who can, in your head, think -2 times 3 is -6, and then x to the 7th. Okay? Pause the video and now give it a try for these 3. Then come on back to compare your answers to mine. All right, you should have gotten 6 times 3 is 18, and a to the 3rd times a to the 1st is a to the 4th. Letter B, -5 times -3 is a positive 15, and I get c to the 9th. And letter C, 4 times 3 is 12, x to the 2nd times x to the 4th is x to the 6th. All right, that's not the only rule you'll come in contact with. Here's another one. What if I have a power of 7 to the 2nd raised to another power? Well, the longhand version of that, what that means is take 7 to the 2nd 3 times. That looks like this. But I'm not done yet, because 7 to the 2nd is 7 times 7. 7 to the 2nd here is 7 times 7. And 7 to the 2nd here is 7 times 7. So really this equals 1, 2, 3, 4, 5, 6. 7 to the 6th power. How could I go from my starting problem to my answer of 7 to the 6th without having to show all of this work? Hopefully you are seeing that 7 to the 2nd to the 3rd power can be found by multiplying my exponents together and saying 7 to the 6th power that way. Here's the rule. Finding a power to a power. To find a power to a power, you multiply the exponents. Here is the example, or an example. I have 2 to the third, and that's 4 times. So 2 to the third times 2 to the third times 2 to the third times 2 to the third. That's what it means. It's important to understand what it means. But then 2 to the third is the same as 2 times 2 times 2. And that's repeated 4 times. Which is the same as 2 to the 12th power. All right, let's apply that to these expressions. 3 to the second to the third. Applying the rule, I would say the answer is 3 to the sixth. Writing it out in expanded form to understand the meaning, 3 to the second is being taken times itself 3 times. Then 3 to the second is 3 times 3. And so that equals 3 to the sixth. Hopefully you're finding meaning in this. You need to make sure you're able to apply these rules. In the last one, a to the sixth to the second, that would be a to the 12th. All right, your turn. Pause the video. Show me that you can do these 3 on your own. Then come on back to compare your answers to mine. Letter A is 2 to the 8th, 4 times 2. Letter B is 5 times 4 is 20, so C to the 20th power. And C is M to the 6th power. Here's some mixed practice of all of the rules we've talked about today. Pause the video, try these 4 problems, and come back to compare your answers to mine. All right, the first one. I'm going to use the commutative property to rearrange the numbers and just multiply the coefficients together and then multiply my variables together. When I have 2 numbers with the same base, I add the exponents. The next one, I'm doing the same thing. This time I'm not going to show all of that work. 5 times 2 is 10. This is y to the first times y to the 8th, so y to the 9th. Number 3. 6 times 4 is 24. Y to the 6th times y to the 3rd is y to the 9th. And then I'm finished simplifying. Now this last one, number 4. This one is a little more involved because I have 2 numbers in there, don't I? So let's write this out. 2y to the 6th times 2y to the 6th times 2y to the 6th. So 2 times 2 times 2 is 8. And then I have y to the 18th. Some of you might have seen that 2 to the 3rd and y to the 6th to the 3rd is the same thing. Now we're going to let you give these a try on your homework. Either way that you did it, you'll get the same answer. And so the homework we're going to have you do is 5 through 25. There's 20 problems where you simplify rational expressions.